Section 3.6 notes derivatives of inverse functions. So we're not going to learn new functions or new techniques to differentiate, but we're going to see today what the relationship is between the derivative of a function and the derivative of its inverse function. So to start here, we are going to look at this graph. And it's going to probably take you a little while to make a copy of this image. You want to do it as neatly as possible. So if we have f here, then the inverse of f inverse, is a reflection across the line y equals x. I've represented y equals x here. So a few tips to make the reflection as neatly as you can is that, of course, they're going to intersect exactly on that line. Right? It's like a mirror. Secondly, we can see on our graph, the point 2, 3 is exactly on the graph. And that means the reflection is going to go through exactly 3, 2. Likewise, you may realize that this is an easy point to draw the reflection from. It's about, 0.8, 0.9. Anyway, it's going to be exactly at the same distance from 1 on the other axis. We can do the same with the point here. This point 0, -1 is going to be reflected on -1, 0 exactly. So taking these few hints, drawing these few points first, you can hopefully make a neat little sketch, and just start again the video when you're done with that. So the question is, what is the slope of f inverse? So I picked a point here, I chose x, it happens to be x equals 3, but just think about it as a general x. And we can see I drew a little bit of the tangent line, so the red line, and the question is, what is the slope of this red line? And you may realize that there's a relationship between this point here and the point across. The slopes are related. Actually, I can show you a little animation that'll also kind of show that. If I move this point here, these two graphs are inverse of each other. If you really focus mostly on these two like arrows, which show the slope, don't focus too much on the triangles, I would recommend. You can see how they act together. And the higher the green part is, the flatter the red one is going to be, and vice versa. So if we go back to our situation, you can see how these are related. And in fact, you may even guess that if f here has a slope of 4, this is going to be a slope of 1 over 4. The steeper this would be, if it was super steep like 10, this would be even flatter, and the slope would be 1 over 10. If for some reason this became a vertical tangent, then here we would have a horizontal tangent. So the relationship is reciprocal. It's 1 over the other. So let's look here. The derivative of the inverse function is 1 over the derivative of the other. But it's a little difficult because it's not simply 1 over f inverse of x. The problem is we are not at the same x. Here, as you can see, it's x equals 3. What is it here? It's 2. So how do I express this 2 knowing that we were at x? Well, this point is x f inverse of x, and therefore that point is f inverse of x, x. Because when you take the inverse, you flip x and y. So if you have x, y, that would be y, x. And in our example, y is f inverse. So altogether, we can guess from geometry that the derivative of the inverse is 1 over the derivative of f at f inverse of x. Algebraically, we can prove that, and what we do is we start with the identity for inverse functions. F of f inverse of x is equal to x. That is the definition of an inverse. If you do something, it undoes it with the inverse of the function. So now we can take the derivative of this equality. The derivative of x is 1, and here we have a chain rule. We have to first take the derivative of f, which is f prime, keep the inside as it was, and then we multiply with the inside derivative, which is the derivative of f inverse. So I'm talking about the derivative of that, which is f inverse prime. And now I can just divide by the front part here, and I get f inverse prime equals 1 over the part I underlined in purple. So this is the formula that we're going to have to know to find the derivative of inverse functions. So let's take an example. Let f of x equals 1 over 4x cubed plus x minus 1, and this happens to be exactly the graph that you could see above. What is the value of f inverse prime at x equals 3? First of all, f has an inverse, so that means we can apply the rule, and we will just plug in the values for the formula that we just saw above. F inverse of 3 prime is equal to 1 over f prime of f inverse of 3. Firstly, we are going to need to find what f inverse of 3 is, and that's not always easy in actual exercises, but we may get hints sometimes in some problem, and in this case we might realize, or we might be told, that f of 2 equals 3. Let's check. If I plug in 2 here, 2 cubed is 8, 1/4 of 8 is 2, so I would get 2 plus 2 minus 1, which is indeed 3. f of 2 equals 3. What does that mean? That means that f inverse of 3 equals 2, because that's just what the inverse does. It kind of flips the x and y. So f inverse of 3 equals 2, I can plug it in here, and now we need to find f prime of 2. That's a lot easier. F of x is a polynomial, so I can find its derivative. Let's do it. It's going to be 3 over 4 times x squared plus 1 and nothing. So f prime, I wrote it here, f prime is 3 over 4x squared plus 1, and I can plug in x equals 2, and I will find that it's 3 over 4 times 2 squared plus 1, which is equal to 4. So final answer is 1 over 4. That's actually what I said earlier. I had that feeling. I didn't know exactly, but it seemed that this was a slope of 4. How did I do that? I kind of extended this line and thought it might intersect here. So that would be 1, 4. So that's why I said 4. And here the slope is 1 over 4. If I extend here, maybe it would just intersect there. So I would have rise over run equals 1 over 4. I was a bit lucky. The AP exam 2008 has a legendary question, if I may say, because it seems that the percentage of correct answers across the world was like extremely small, maybe 10% of students got the right answer. And when you think about it, it's kind of humorous, because if you kind of try to give pencils to your pet dog or your pet cat, and you let your dog or cat just choose a question at random, well, with all the animals in the world, they would find 20% of them would get the right answer, whereas humans, we only got like 10% correct answers on that question in the real AP exam. So how do we solve this question? It's not so hard once we know what to do. Here we are given a bunch of stuff. We know that f of 3 equals 15, f of 6 equals 3, f prime of 3 equals negative 8, f prime of 6 equals negative 2. It is said that g is the inverse, so g is actually f inverse. And the question is, what is g prime of 3? So let's try. G prime of 3 means f inverse prime, so we can just apply the formula we saw above. And now we are in the situation where we need to know what g of 3 is. As we scan here, g of 3 is not given, but g of 3 is g is the inverse of f, so here's the key point. If f of 6 equals 3, that means g of 3 equals 6. Therefore we can write 6 here, and now what is f prime of 6? We look in the bunch of stuff we are given, and we find that it's equal to -2. So final answer 1 over -2, answer A. So you were given extra information that we never used. This might happen sometimes in questions in AP Calc AB. So when we talk about inverse functions, some of the more popular ones are inverse trig functions like arcsine, arccosine, arctan. Here's all of them. There are 2 specifically that you will need to memorize. It's arcsine and arctan. The other 4 are never asked for in AP exams. These 2, you're going to need to know them by heart. So we can prove that the derivative of arcsine x is 1 over the square root of 1 minus x squared. It's a nice proof. So we start by saying y equals arcsine of x, and we take the sign on both sides. So sine of y equals sine of arcsine, which cancels out, so it just becomes x. And now I can use implicit differentiation. The derivative of sine y is going to be cosine y times the inside derivative, which is y prime, equals derivative of x is 1. And so I quickly reach the place where I can say y prime is 1 over cosine y. That's great, but as we see here, we would like an answer in terms of x. So we need to make a sketch. I could have drawn the unit circle around here, but the radius is 1. And if the angle is y, then sine of y, here, sine of y is equal to x. That's given. So if the angle is y, sine of y is on the opposite side. It's here. And now I can use Pythagoras. If I know that the hypotenuse is 1 and the opposite side is x, I can say that the adjacent side is square root of 1 minus x squared using Pythagoras. But this side also happens to be cosine of y. So I can substitute, instead of cosine y, I can write square root of 1 minus x squared, and we have our answer. So that's it for today. It's, in the grand scheme of things, it's not a very big section. There's 1 formula for inverse, and then there's 2 formulas for inverse trig functions. It doesn't have as much weight in the AP exam as several of the sections we've seen in Chapter 3 until now, but of course you still want and need to know it. Thank you for your attention.